let's proceed to one. Second example. Here we have a 10 kilogram block that is subjected to the forces shown. So we have two conditions on this one. We have we have case A and then we have case B. And then each block, these blocks, has the same mass, that is 10 kilograms. And then this is being subjected to the forces shown. So in case A, we have a force here, 200 downward, and then 40 newtons to the right, 30 newtons to the left. In case B, we have a force that is equal to 2.5 S newtons. So in force A, take note of the forces. In force A, the forces are constant. So expected that the acceleration here is constant. In force B, you can see that the force is uh, proportional to its distance traveled or to its displacement. So it means that kung magkano kadako iyang gibiyahe, the greater the distance it traveled, therefore it required a greater force. Since the force is increasing as it travels, therefore the acceleration is not constant, it is also increasing. So the second one is not a constant acceleration. So say purpose ani, so that is just determining if we're going we can use the constant kinematic equations or not. So in the first one, you can use the constant acceleration kinematic equations. In the second one, we're going to use the integration or differentiation. Okay, so we have here a mass that is equal to 10 kilograms. We have two conditions. We have case A and case B. Mass is 10 kilograms. So our weight, that is the mass times the gravitational acceleration, that is equal to 98.1 Newton. In each case, whereas in each case, determine its velocity at s is equal to 8 meters. If velocity is 3 meters per second at s is equal to 0. So we have an initial condition. It says that at 0 meters, or starting from s is equal to 0, the velocity is equal to 3 meters per seconds. And then at s is equal to 8 meters, a distance equal to 8 meters, whereas to find the velocity. So similar situation from our first example. And then we have here a motion occurs to the right. So take note they know that the motion is horizontal, acceleration towards the right is 0. No, sorry, towards y is 0. Acceleration towards the right or x is, there is an acceleration towards the right. Okay, let's start solving this one. Okay, let's start with the case A. First is draw the free body diagram. Now, in case A, you notice that there are two horizontal forces acting on this object or on this body. We have a 40 and 30. They are opposing. So, aron mas dali to have an easier plotting of forces in our free body diagram, and then dili na kay siya gubot, you just determine the remaining force with this one. We have a 40 Newton towards the right. So all forces towards the right should be positive. Minus 30 newtons, that is towards the left. Then the horizontal forces acting in this one is just 10 Newton. So this is just for hand-eye ang inyong pag-graph or pag-plot sa forces in our FBD. So we have FBD here. This is the X, this is the Y. The acceleration is, or the motion occurs to the right. So we have here a 10 Newton force acting to the right. That is already in consideration to the two opposing forces, 40 Newton and 30 Newton. So we have a 10 Newton here. You also have 200 Newton downwards. That is a force. Don't forget the weight that is going downward. That is 98.1 Newtons. What force do we have? Other force do we have? We have a normal force and C. So generally, so normal force is only useful when there is a friction. And for, in this given problem, we can't see anything, we can see any friction. There is no coefficient of friction. Therefore, there is no friction. It is assumed that the floor here is smooth. There is no resisting frictional force. So this is just a very easy. Next is after plotting the FBD, and then you try to solve some forces. So you don't need to solve forces along Y because the normal force is useless with this one. The floor is smooth, there is no frictional force, and then automatically you can solve for the summation of forces along X. That is equal to the mass times the acceleration towards X. So the summation of force along X is just equal to 10, and then there is no other force. It's equal to mass. Mass is 10 kilograms, and we have the acceleration along X. Therefore, acceleration along x for our case A is equal to 1 meters per second squared. Now, we can determine the velocity with this one. Again, already established in the first place that this one, the acceleration is constant because the forces is also constant. They are not increasing through time or increasing through distance. So the force is not a function of time nor a function of distance. So we can use this one. If the square of the final velocity is equal to the square of the initial velocity plus twice the product of our acceleration, the constant acceleration, and its displacement. So that is the final position minus the initial position. So the velocity at s is equal to 8 squared is equal to the initial velocity. Our initial velocity again for this problem is 3 meters per second squared. So that is t squared plus 2 times our acceleration is 1 times the final position is 8 minus initial position is 0. So we have here the final square of the final velocity is equal to 9 plus 16 square of the final velocity is equal to 25. Subtract to square root on both sides. Then we already know that the velocity of the block shown with the forces acting on it at s is equal to 8 meters is equal to 5 meters per seconds. And then we already have the answer. This is very simple. So next one, what do we have here? So the next one on the same given, except on the force. We have the weight is equal to 98.1 Newton. Acceleration is towards the right again. It's this distance 0 meter. The velocity is 3 meters per seconds. Initial velocity at s is equal to 8 meters. We need to find its velocity. Same problem. And if we plot, first again, we'll draw the FBD. So we have an FBD here. This is the X, this is the Y. So we have a force towards right. That is equal to F is equal to 2.5 S. The acceleration is also towards right. Now in this one, in the FBT, we can disregard the forces acting along Y because it has a smooth surface. It is useless. It does not resist or does not affect the motion of our block. Pwede na nato ibutang si force along X3. Next, we solve force along X is equal to mass times acceleration along X. So everything that moves to the right or to the positive x-axis is positive. So we have 2.5 s is equal to the mass, which is equal to 10 kilograms times the acceleration. Therefore, our acceleration is 0.25 s. See, our acceleration is a function of its distance traveled. So it means that the acceleration is not constant, it increases as the displacement or the distance traveled by the block is also increasing. So we cannot apply the constant kinematic equation. So we use the what are we gonna use to get the velocity? We cannot use a is equal to dv over dt because the acceleration should be in the equation as a function of time. Kasi bato na to, we need an equation that shows the acceleration is in a function of distance. So if you remember, no, we have the formula v dv is equal to ads. Ano na siya? So the velocity with respect to the velocity times is equal to the acceleration 0.25 s ds. Now if we integrate both sides, so in a velocity, our lower limit is 3 meters per second. Upper limit is unknown. We need to find the upper limit. And our distance, lower limit is 0 because it starts from the origin as 0 until s is equal to 8 meters. So we have 1 half of v squared from 3 to v is equal to 1 half times 0.25 s squared from 0 to 8 meters. We have a 1 half on the left and on the right hand side of our equal sign. We can cancel that one. They cancel out each other. So we are left with the v squared and then the 0.25 s squared. Now let's solve for the apply the upper and lower limits. We have the v squared minus 3 squared is equal to 0.25 times 8 squared minus 0 squared. So we have here v squared minus 9 is equal to 0.25 times 64. So that is v squared minus 9 is equal to 16, or v squared is equal to 25. Subtracting the square root on left and the right side of the equal sign, then we have that the velocity di of the block at 8 s is equal to 8 meters is equal to 5 meters per seconds. So this is just a coincidence of the problem. Note that both the velocities in both conditions are the same. But we know that in the second one, the velocity will be different because in the next or in the succeeding distances, because the acceleration also increases with distance. That is the second problem.